Many organisms increased in size, strength, and speed during the Ordovician, although most marine life remained quite small. The sea saw the arrival of jawless fish that exhibited a major development in vertebrate evolution, bony plates and scales. Microvertebrate faunas contain animals that are known from bits of bone, scales, or teeth, generally obtained by breaking down large quantities of rock, often by acid preparation, and then patiently sorting through what remains. Ordovician rocks from around the world have proved to be a rich source of microvertebrate fauna, which have revealed new lines of vertebrate evolution. Bony plates, scales, and possibly teeth appeared for the first time in vertebrates in the Ordovician, but the reasons for the evolution of these characteristic vertebrate features are still poorly known. Bone is composed of calcium phosphate, and some scientists have suggested that it evolved as a way for the animal to remove excess phosphorus from its body, and perhaps to then use the bony skeleton as a phosphorus reservoir, available to be reabsorbed when needed. Phosphorus is an important component in several physiological processes. Bony plates and scales could also have evolved as a means of providing protection against predators or parasites, or as insulation for electroreceptors, sensory organs sensitive to electrical signals. Conodont elements are microfossils that are widespread in marine sedimentary rocks from the late Cambrian to the late Triassic. They were first described in 1856 as tiny tooth-like elements, and became a useful tool in the dating of rocks. However, their origin remained a mystery until 1982, when a fortuitous discovery in a collection finally associated conodont elements with an actual animal. This conodont animal, from Carboniferous rocks in Scotland, possessed V-shaped muscle blocks and what appeared to be eyes at the front of the body. Another conodont animal, from Ordovician rocks in South Africa, appears to have had muscles associated with the eyes. Held within the body, in the approximate region of the gill arches, were the conodont elements. Their assembled arrangement and the wear patterns on these elements were suggestive of a feeding mechanism. Conodont elements are said to be made of bone and enamel, and all of these features are characteristic of vertebrates. Despite this, the identification of conodonts as true vertebrates remains controversial.